All right, so we are doing solving systems of equations. I'm going to get rid of that. We are just going to do this all in one day, so I'll get rid of that. So we are doing inequalities now, systems of inequalities. So learning goals for this lesson: I can write a system of inequalities when given a graph, determine if a point is a solution to a system of inequalities, determine if a region represents a solution to a system of inequalities, and determine if a point lies in the area that is a solution to a system of inequalities. And finally, identify an error in a graph that represents a system of inequalities and describe or correct it. So when we're talking about systems of linear inequalities, they are basically the same as linear equations as far as like how you set them up in the graphs and everything. But remember, with an inequality, we shade above or below or to the left or right of the line. So for example, also the line can change. If we look at what we have here, the overlap of the shaded areas will be considered the solution. So let's say I have this graph, it's shaded below, this graph is shaded to the left. The area where they overlap, any point in there would be considered a solution. All right, so now, assuming that y is on the left of the inequality, this is just a refresher. Less than, dashed line, shaded below. Less than or equal to, dashed or solid, shaded below. Greater than, dashed, shaded above. Greater than or equal to, or solid, and shaded above. So just as a refresher. So let's dive right into the first example. We need to write a system of inequalities that represent the graph below. So I'm going to start with the dashed line. We've got y is less than because it's dashed and it's shaded below. The less than is so that we know that it's below. The dashed means it's not less than or equal to. All right, so now we're going to go ahead and look at where it crosses the y-axis, which is right here, and that's at -6. Okay? So we have -6, and then we go up 3 and right 1. So it's got a positive slope of 3x. Now we go to the second one. We know that y is greater than or equal to. It's or equal to because it's a solid line, greater than because it's shaded above. And it crosses at a +3. And then we go down 2 and right 1. Since we're going down, it's negative, and it'd be -2x. Second example, we want to know which of the following ordered pairs is a solution to the system of inequalities. So we've got our system here. You don't need to worry about trying to figure out what the graph is. All you need to do is look at it. We're going to start off by putting all of our points on the graph. And we're going to look for the one that's in the overlapped region, which only is D. That's this one right here. Okay. Just a quick note. If I had a point that was right on the dashed line, that wouldn't be a solution because anything that's on the dashed line is not a solution. However, if I had a point, say up here, that was on the solid line, that would be a solution because anything on the solid line is also considered a solution. And so it would be a solution to this one, and it's in the shaded area above the dashed line. So that would work. Okay, now we want to know which letter represents the solution region for the system. In other words, which entire region. So we go ahead and we graph both of these. So -1, so greater than or equal to, that's this line right here. Less than or equal to is the other one. And the way that you tell which line is which is go ahead and just, all you need to do is look at where they intersect the y-axis. And then you can tell from the overlapped area that it is in fact C that's in the solution region. Next example. So I'm going to go through these a little bit out of order. So I'm going to go ahead and I'll do this one first. Okay, and it's y is greater than 3. So it's a dashed line because it's greater than. It's not greater than or equal to, and we shade above because it's greater than. Next, I will do this one. And that's a solid line, and its y is less than. So we put this line, started at 3, went down 1, right 3, and that one's shaded below. And then finally, x is less than or equal to -2. So just like with linear equations, when we just have something like this one or this one, we find x is -2. It's a solid line. And then because it's less than, we shade to the left. So we want to know if -7, 5 is in the solution set of the following inequalities. negative 7.5 is right there. And because it's on the solid line, so this is a solution area right here. Okay, right in here is a solution area because that's where all three overlap. But because it's on the solid line, that is in fact a solution. And finally, student graphs the system as shown below. Describe and correct the student's error, express a correction or words on the graph provided below. So I actually went ahead and I put this one on there already. All right. What I had to do was, excuse me, I had to switch this. So basically I subtracted 1/2 from both sides because I've got to get that in 1/2 x, I had to get that in the correct form. So y is greater than negative 1/2 x. And if you want to leave the plus 0 in there just to make your life easier, great. This should actually be a dashed line. So I'm going to go ahead and I'll fix that. So I can do that just by that. Okay, so if I compare that to my other one, so far that looks correct. It's shaded above, this is shaded above, it's a dashed line. Okay, you get the idea. Alright, so next one I want to take care of is x is greater than or equal to negative 2. So if we do greater than or equal to negative 2, it's actually shaded on this side. Okay, that's not true over here, so that's one mistake. Let's see if the other one is correct. And y is greater than 2, that's that. So the actual correct area that should be shaded, yep, I'm going to put that line in there. Oh, let me go back. Sorry, technical difficulties. The actual solution is in here because that's the only part that has all three. So this is shaded above, this is shaded above, this is shaded to the right. So this is the only one, this is the only area that's the solution. So you can either just graph it, or you can say, oh, shaded to the left of x is greater than or equal to negative 2 instead of to the right, since x, not y, is greater than 2. And that's it. That's all you have to do. Tips, just a quick few tips. Remember, if the inequality faces a variable, it's greater than, which means you shade up. If it faces away, you shade down. Makes sense if you think about it. And then finally, do not forget that the solutions are in the shaded areas that overlap only. So that's the only place. So 2 videos in one, it's a little bit longer, but at least there's only one video that you have to worry about. So you guys have a good one. Take it easy. And we only have one more target for this section before we are done with this particular section. So keep it up, guys.